Labs, who's going to explore the possibilities of digital manufacturing with us. So if you're wondering what it's all about or want a bit more knowledge, then Richard's here to help. Just before I hand over to Richard, so he can introduce himself and get going, just want to say that the event is being recorded, so I've set that going. That's so we can share with others who are not able to attend. Might be best to turn your cameras off during the presentation, just to save on bandwidth. I think most of you have. If you have any burning questions as we go along, you can always put your hand up. You can always put your camera back on and then ask the question if you feel comfortable. Otherwise, put any questions in the chat as we go along, and Richard will answer them at the end. Okay, I'll hand over to Richard now. Thanks, Richard.
Excellent. Thank you very much for that introduction, and thanks everyone for coming. Andrew, if anyone does ask any questions or put their hand up, I've minimised the Teams thing now, so I'm looking at my presentation. So if anything pops up, just let me know.
I will do, yeah.
And I can answer that. But if I crack on, I'm going to be talking about digital manufacturing. So before we go on, I've been introduced now, but I'm Richard Anthony. I work for Protolabs, and I'm going to talk a little bit more about what Protolabs does. I'm a senior application engineer there. I've been with the company over 12 years there, and in my role, I talk to our customers, who are typically engineers, designers, anyone who are involved in the design and manufacture of new products, and I help them with design for manufacture for any of our 3 manufacturing processes that we offer. So within this presentation, firstly, I'm going to explain who Protolabs are and what digital manufacturing is. So Protolabs does digital manufacturing. Briefly at the end, talk about some case studies of projects that Protolabs have been involved with. And then right at the end, just pointing out some additional resources that we have on offer. So before I go on, has anyone had any dealings with Protolabs?
Not me. Is it me, or you seem to be freezing, Richard? Has anybody else got the same problem?
If that's going to be an issue, just I do that for now. Is that any better?
No.
Am I still there?
Yeah. Yeah, you are. Yeah, I think you were freezing, yeah. So, Matthew Oxley has said yes to both. I'm not sure if that's yes to freezing or yes, he's heard of Protolabs. Might be both. Both, yeah. So Matthew's heard of Protolabs.
Are you guys still able to hear me?
I think it's quite intermittent.
Yeah. Can you guys hear me now? Is it a connection issue? All right, I'll crack on. Let me know if it does break up, and obviously I'll stop talking. So talk a little bit about who Protolabs are. I'm going to let this little video play. Hopefully the bandwidth is enough to let it play. There's no words on this, so if you could just read the text on the screen. But I like to play this little video because it gives a bit of an idea of the sort of environment, our manufacturing environment, the sort of scale we have within our factory. Within what you can see here, this is our injection molding facility and our CNC machining facility. So I'll just let that play. The reason I like to just play that video is just to give people a sense of the manufacturing environment that we have, the factory. If people have had any experience of dealing with Protolabs, or perhaps you've looked at our website, you can see lots of information on our website. But I think nothing beats actually seeing the manufacturing environment that we have. So hopefully that gives a bit of an idea of the sort of scale that we're working at. What we're looking at here is a map of all of our sites. So we've got some green dots on here and we've got some blue dots. The green dots are our digital factories, as we call them. That's our in-house manufacturing. And then the blue dots relate to our digital network. And I'm going to talk about those two things a little bit further on into our presentation. But you can see that we have presence in Europe and North America. So we're an American business, but I work for our European business based in Telford in the UK. We also have a manufacturing facility in Germany, and we have sales offices in France, Italy, Germany, and in Sweden. And then I'm going to talk a little bit about what we mean by digital manufacturing. And really, by digital manufacturing, we're talking about the digitization of kind of everything that's within the manufacturing loop. That's from how CAD files are handled, how they're uploaded into the system, how we handle those CAD files in our system and communicate back to you with design for manufacture feedback, all the way through to placing the order through an online system, through to the shipping. Everything is in a digital loop. I think most people perhaps would associate digital manufacturing with maybe additive manufacturing, 3D printing. But as you'll see as we go through this presentation, it's really any manufacturing process that can be automated through a digital thread. So next we'll talk about a little bit why we might want to use digital manufacturing. So I've got a little bit of an animation here, and this is a comparison between a rapid manufacturing process and a more traditional manufacturing process. So I'm just going to pause it when it completes. So leave it there. So what we're looking at here is, we'll pause. Yeah, there we go. Hang on. It's going to loop round. So we've got the top line, which is the rapid manufacturing process, and then the bottom line. So if I look at the bottom line, which is the traditional manufacturing process, you can see here the stages from rapid prototyping to iterations to the builds and then on to validation. All of that obviously takes some time. So what the rapid manufacturing process does, it can take out lots of time from that process. It can compress all of those elements. So from using 3D printing and CNC machining to get those initial prototypes through to a rapid injection molding process that might take a matter of weeks rather than months from a traditional process. That might allow you to do more iterations. It allows you to identify problems more quickly, so you have more time to deal with those problems, and it basically allows you to get your product to market faster. So it's all about speeding things up. Obviously, the sooner you can get your product to market, if you can beat your competitor, you have an advantage there. There's obviously a need for that. On this next slide here, we're looking at, this is an example of the sort of feedback that we provide to customers. In this case, we're looking at an example of an injection molding quotation. So for each time a CAD file is uploaded into our online system, we have a piece of software, and we also have a team of analysts who look at that CAD file and provide lots of feedback in relation to whichever manufacturing process is being considered. So in this case, it's injection molding. So we're highlighting lots of things that would be things that need to be considered, for anyone who's offering an injection molding process. So things like thin areas and thick areas, looking at inconsistent wall thickness. But there'll also be lots of things that are maybe a little bit more particular to the fast lead time injection molding process that we offer. So our tools are all made from aluminium. They're all CNC machined mold tools, and we use aluminium and we CNC machine for speed, so we can produce that mold tool on a very fast lead time. Our standard lead times for injection molding are 15 business days. so 3 weeks. But equally, potentially we can offer a 1 business day lead time. That's 1 day to manufacture the mold and then mold those sample parts and ship them to you. So we provide all of this feedback in a 3-dimensional view that you can rotate within your online account. So everything is very transparent. You can see all of this information before you place the order. You can use this feedback to inform your design process. So we have lots of customers that we work with that will know our process, know what the sort of information we can provide, and they'll upload their designs, their CAD designs at a very early stage, and they'll get our feedback and they'll use that to inform their design process, rather than trying to design the final part, uploading it into our system for us to then point out things that need to be adjusted. So they'll use this service to inform their design process. And this, like I say, this is something we do for every single CAD file that a customer uploads into our system. For this example here, we're looking at injection molding, but we also provide feedback for our CNC machining process and our 3D printing process.
Richard, what file formats do you use?
Yeah, we can accept multiple file formats, most of the main ones. Step and IGES tend to be the best ones. So the software that we use to produce this analysis, and it's also the same software we use for designing the mold tools, that opens Step and IGES files directly. But ultimately, we can convert, if you send it in a different format, we can convert it into that. So SolidWorks files, but Step and IGES are the main ones. They give us the least challenges.
Yeah, cheers.
And then I'm going to talk a little bit about our manufacturing processes. So when we were looking at that map before with all the dots on, we had the green dots, we had the blue dots. The green dots were our digital factories, so our in-house manufacturing. This is where, in that video that we saw, this is the digital manufacturing in the Telford site that was doing the injection molding and CNC machining. So I'm going to go through the 3 manufacturing processes that we offer in-house, and then I'll talk a little bit about what I mean by the digital network. So firstly, we have 3D printing services. So we offer stereolithography, selective laser sintering, multi-jet fusion, polyjet, and 3D silicon, and direct metal laser sintering. As it says there, 1 to 50 parts. So generally low quantities of parts, either for prototyping or maybe low volume production. And we're offering pretty fast lead times, 1 to 7 business days is the typical lead times. And like I say, we offer plastic processes and we also offer metal processes. The metal 3D printing process is increasingly being used to produce end-use parts, so being used as the manufacturing process, but it's also used to prototype parts that are going to be maybe sheet metal formed or cast in the long run. We also offer a CNC machining process. So this CNC machining process is very much focused on offering fast lead times. So typically 1 to 3 business day lead times. And the quantity of parts, it says 1 to 200. 200 would be quite a high quantity for our CNC process. Typically 1 to 50 parts, that sort of quantity. And we're offering it in a range of plastics and metals. It's a 3-axis CNC machining process primarily, but we can also do a 5-axis indexed machining process. So for the 3-axis, we can take the billet of material and we can rotate it and do it from potentially 6 orthogonal sides. With the 5-axis indexed machining, we can take the same block, but instead of only rotating it 90 degrees, we can rotate it at any angle. The block then stays at that angle and we do the machining process. And we also offer a turning process. So CNC lathes, a combination of turning and live machining there. The way our online system works is you'll upload your CAD file and our analysis software will work out how much of the part can be machined. So we have a fixed cutter set. Things have to be more limited to offer the fast lead times that we do. So it's not uncommon for there maybe to be some small radiuses or a deep slot that we can't access with any of our cutters in our cutter sets. So what we do is we'll highlight that within the 3D view within your online account. So you can have a look, you can see where any leftover material might be, and you can make an assessment as to whether that's going to be a problem, this part, or whether in this situation you can accept a larger radius or maybe a slot not being formed all the way down. You may even decide that even though maybe we can't form a hole in the side of your part, getting the part in two days is still better. You can get the part in 2 days, you can then do some post machining yourself, rather than going to a machine shop that might be able to do the whole part in a much longer lead time. So we have customers that use this in those different ways. And then finally, we've got our injection molding process. This is our main thing that Protolabs does. It's the majority of what we're doing. It's the process that we started off doing. So this is a rapid injection molding process. So 15 business days is a standard lead time, and if we can do it faster, we'll offer faster lead times as well. So the way we generate that speed is a combination of how we analyze the CAD file to begin with. So we can very, very quickly determine whether a CAD design is suitable for our injection molding process. We can highlight lots of feedback, as the example in that online quote in the previous slide was showing. So we can provide all that feedback. We can work with you with adjusting the design if it needs to be adjusted. We can either let you know what those adjustments are so you can make them, or we have a team of people who can make adjustments. We don't do wholesale designing of CAD geometries, but we can make adjustments to CAD geometries to bring them in line with what we need for our manufacturing process in a way that works for the end function of the part. So we analyze the CAD file very quickly. We use the same piece of software to help us design the mold tool. All of the mold tools are CNC machined. We work with aluminium for the mold tool, so we can produce that mold tool very, very quickly. But then the actual molding process itself is a completely normal traditional molding process. Normal injection molding presses, normal injection molding materials, all the same considerations from a more traditional injection molding process. We're just working with a mold tool that's been produced on a very fast lead time. We have a range of stocked materials that you can select from a drop-down menu within our quotations in the online system. They're designed to cover as broad a range as possible. But equally, if there's a particular material that you're needing, you can either supply that to us, or we can source it for you for your particular job. And as long as it's suitable for the injection molding process, we'll be able to work with it. We can work with a decent level of complexity within our mold tools. So we can have things like mold inserts, we can have sliders, we can mold over threaded inserts, we can do over molding. There's all sorts of things that we can do. We can confirm all of that before you place the order. So the idea is we've identified all the challenges, we've confirmed everything up front. So when you place that order, it just sails through our manufacturing process, going from mold manufacture to our milling department to shipping and out the door, or which is a little bit different from a more traditional molders that might give a initial cost, and then when the order's in, then they have a look to see whether anything needs to be adjusted. We do all of that up front to try and compress that lead time for the manufacturing process as much as possible. And we also offer a range of secondary services. So these are things that aren't done by default, but things that we can potentially add on. So things like various surface finishes within the mold tools that we don't do by standard. Threaded inserts I've talked about, that's either molded in threaded inserts, or maybe we can glue them in if it's a 3D printed part. Pad printing for things like logos on parts. Laser engraving for fine detailed part marking. We can offer that. Basic assembly, that's more for 3D printing if we've got an assembly of parts, or maybe a part is too large to print in one piece. Inspection documents, dimensional inspection, anodizing for metal parts. Chromate conversion, that's for metallic parts. Vapor smoothing, that's a surface finish for 3D printed parts, which smooths the surface finish. And then lots of painting and custom finishing, that's generally for 3D printed parts. So there's quite an extensive range of secondary services, and generally what we say is if you've got a requirement, let us know, and then we can make an assessment on whether we can do that. Our standard manufacturing processes are very streamlined to be able to offer fast lead times, but where we can, we will always try and branch out into these additional services where they're required. We just need to make sure we're doing it in a way that doesn't undermine our main offering, which is providing parts at speed. And then this brings us on to the digital network. So a couple of years ago, Protolabs acquired a company called Hubs, which was a company with a head office in the Netherlands. They have something called a manufacturing network. So this is a network of approved manufacturing partners, and these can be all around the world. You can see on that map where the blue dots were dotted around the globe. These are manufacturers that Protolabs/Hubs have approved, confirmed that they're working to the quality required. And the idea is, between all the manufacturers in that network, we can offer a very broad range of manufacturing offerings. Primarily it's CNC machining at the moment, but it also includes 3D printing and injection molding. So the idea of this network is, if it's something that we can't do within our digital factories, we can then look at the network to see whether the network can offer things. So things like, if you need a part CNC machined in a very specific material, and it's one that we don't work with within our factory, then we can go out to a manufacturer within the network who can offer that material. Another advantage of the network is we can work with CNC machinists who specialize in producing high quantities of parts. So within our digital factory, you're unlikely to be ordering large quantities of parts, because it's very quickly going to become very expensive, because we specialize in a low quantity of parts in a fast lead time. But if you need a higher quantity of parts, and perhaps the lead time isn't the main factor, then the digital network is going to be able to offer a very competitive price to be able to do that. So this is something that is relatively new addition to our services. So over the coming years, you'll probably see more things. At the moment, in terms of the websites, they're separate websites, but they will over time become a single thing. And the idea is, you'll come to us with your what you need, the quantity of parts, whether you need a fast lead time, all of those requirements, and based on those requirements, we'll determine where the best place to manufacture your part is, whether it's within our factory or whether it's within our digital network. And there's just a slide here on the sort of quality control we do. I'm not going to linger too much on this, but we can do various quality control things in terms of our digital network. All parts that are manufactured by one of our manufacturing partners, those parts, if it's within Europe, those parts will come to our Amsterdam office, where they'll have their quality checked, and any custom clearance, all that sort of documentation will be done before being shipped out to yourselves. And we can do various quality checks, and if you've got any particular requirements for quality checks, then let us know beforehand and we can have a conversation about that. And then I've got some examples of case studies. So the nature of the Protolabs business model is we work with literally hundreds, probably thousands of different companies each year, all making their own products, all involved in a whole range of industries, lots and lots of different applications. Most of those things I can't talk about, unfortunately, because of confidentiality, which obviously we take very, very seriously. But we have some projects that we can talk about where customers have agreed that we can use them as case studies. So we've got a few examples here to talk about, just to highlight the sort of projects that we get involved in. And we've got one for each of our manufacturing processes. So this first one here is for General Drones, and it was 3D printing that we helped out here with. So General Drones are making a drone that is used for search and rescue at sea, and where we were able to help them with was with some 3D printed parts, I think mainly for the outer casings of the parts, and maybe some things inside. We used multi-jet fusion and selected laser sintering, which are two powder-based processes that can produce quite durable parts, weather resistant. You can make them watertight. Multi-jet fusion parts are watertight straight off the machine, and selected laser sinter parts can be made watertight the vapor smoothing process can do that, as well as smoothing the surface of the part. So this is an example where customers used our 3D printing services to help with their the development of their, in this case, a drone. Next, we've got an example that we've used for injection molding. So this case study is a medical device. It's used brain simulation for the treatment of depression, but what we were involved in was injection molding the casings. So the plastic casings that are holding the technology that this company has developed. So we were able to support them with design for manufacture feedback. Parts were produced with a biocompatibility and flammability rating. And one thing to point out, particularly for injection molding, is injection molding is a relatively complex thing, and it can be complicated to design parts right for injection molding. And lots of the time we deal with customers who they're very expert in the technology that goes inside the box, if you like. They're not necessarily expert in the manufacturing process that we used to make the box. So there's lots of pitfalls, and the nature of Protolabs' business, we can be working with a very large automotive company who has lots and lots of expertise, and at the other end of the spectrum, we can be working with a one-man band, perhaps inventor who's come up with a new product and is trying to develop it and bring it to market. That sort of person will have a lot less manufacturing knowledge and will need lots of support to help them optimize their design for a manufacturing process. And that's where we can come in with our design for manufacture feedbacks that we put on our quotes, and also our team of engineers. I'm one of that team where we can have Teams calls, we can have face-to-face conversations where we talk about all the issues, we talk about the risks, we talk about potential solutions to things, so we can make sure that things are designed as good as possible before they then commit to an injection molding tool. But even then, there's possibilities to do modifications to mold tools to tweak things if they need to be done. So this particular company benefited from our collaborating with us in terms of designing the parts, optimizing them before they committed to the injection molding tools. And then the final example I'm going to talk about is one where we supported from a CNC machining point of view. This company makes satellite components, so I guess space industry in this case, and we were supporting with making aluminium PEEK and acetyl POM parts from our CNC machining processes. So things like helping with the brackets, so parts that have structural elements within the parts. So we were able to supply those plastic and metal parts on a fast lead time to support their development process. And then just on this next slide, it's basically a collage of lots of different examples, but I'm not going to talk about all of these, but what I want to point out is the variation of things, the variation of industries. Some of these things are medical products, some of them are robotic things, some of them are consumer electronics, some of them are very arty things. The picture in the middle at the top, that's a 3D printed dress that someone wore at the Met Gala in New York a few years back. So it's really using the process as a kind of to make artistic pieces. So it's a whole range of different sorts of products, different sorts of industries. The majority of what we're doing is automotive and medical and consumer electronics, but basically our manufacturing processes and what we offer can be useful for anyone who's developing new products and has a benefit to get them done quickly and with fast lead times. And then just finally, I'm just going to talk a little bit about the additional resources we have. So within our website, we have something called Inspiron Academy, and this is some online training. It's CPD accredited, and this is some training that is giving a kind of basic foundation of all of our manufacturing processes and how they work. And this is something that is free of charge. You just need to go into our website and sign up to do it. And it's probably a great thing for perhaps a student or someone who's new to the workplace, or someone who isn't familiar with one of the manufacturing processes that we offer. It can be a good foundational thing to learn a little bit about the process, to then build on that moving forward. We've also got our blue sample cubes, which are in the middle there. I don't know whether you've ever seen these at any trade shows or anything dotted around. These are a plastic part. It's been injection molded. The idea of this part is it's a design aid. It has some good and bad examples of designing for injection molding, and that can be a useful thing if you're designing parts. I frequently find I'm talking to design engineers about topics, and if they've got one of those at their end and I've got one on my desk, you can really use it as a useful tool to explain various design features and good and bad things. And we've also got lots of white papers on our website, lots of design tips. Our website is a wealth of information, both on what Protolabs is doing, but also about the industry as a whole. So if you're interested, you could have a look on there to see what white papers we have. And that is it. So hopefully that was of interest. I don't know whether you have any questions on anything I've just talked about.
Yeah, thanks, Richard. That was really interesting. Bit of a whistle-stop tour through digital manufacturing. Yeah, as Richard says, anybody got any questions for Richard? Any thoughts, comments, observations?
What I would say is, if you think there might be a need, it's as simple as dropping the CAD file into our website, and you'll get the feedback. And then you don't need to be talking to anyone. You can get that automated feedback, and you can get a really good idea in quite a fast lead time of whether we're going to be able to offer something that is suitable for your project, or whether some other manufacturing process is the best offering. So I'd really encourage you just to, if you think there might be a need, drop the CAD file in, and we can tell you, in a matter of hours potentially, what we could offer.
Yeah. The animation of the traditional and rapid
Yes.
manufacturing process.
Mm-hmm.
Can you go back to that, please?
Yeah. It's here somewhere. Yeah, this one here.
Yeah. So, just a little question on the first stage of the process. The top one and the bottom one, it both says 3D printing, CNC machining. I'm wondering what is it you're doing differently? I mean,
yeah, I mean,
go from like 1 month to 1 week, or 3 months to 3 weeks there.
Yeah, I mean, for 3D printing, I mean, the lead time is really dictated by the machines themselves. So there probably won't be a great deal of difference in lead time for the 3D printing services. But when it comes to CNC machining, we can offer potentially a same business day lead time for a machined component, or our standard lead time is 3 days. So that is usually quite a bit faster than perhaps a traditional CNC machinist. So you can get your parts faster. You maybe then have time to do a couple of iterations at that stage before you get hit a deadline. They're probably the main differences. We do offer fast lead times for our 3D printing process, but the main difference between a more traditional process would be the CNC machining, where we've really optimized how we're creating the tool pathing to machine that part, and it's all very, very automated.
Yeah. Okay. Then you're using aluminium tooling initially,
Yeah.
and then are you swapping to steel at the back end, depending on quantities, I suppose?
We just work with aluminium mold tools. So we have, for our injection molding process, we have 2 mold life options. So when you place an order for a mold tool, we have what we call our prototyping mold life, and we also have an on-demand manufacturing mold life, limited and unlimited. So with the limited mold life, we guarantee the mold for 2,000 parts off that mold. You'll see a lower mold cost and a slightly higher piece part price. So the idea there is you make the saving on the mold tool because you're never going to have that many parts off it to make a saving in the long run on the parts. Or you can have the unlimited mold, where we guarantee the mold tool for however many parts you need. So even if it's an aluminium mold tool, it's likely to wear a little bit faster than a steel mold tool. But we'll look after all of that maintenance. We'll even replace the mold tool if we need to. There's no additional charge for the mold. Yeah. The mold cost is slightly higher compared to the prototype mold, but the piece part price is lower. So if you're having 10,000 parts plus, having that piece part price lower is a greater advantage because you can save more money in the long run, and paying a little bit more for the mold cost initially is usually less of an issue, and that additional mold cost covers the ongoing maintenance. So to answer your question, they're all aluminium mold tools, but if the durability and the longevity of the mold is a concern, then it's I'd advise you to go to that unlimited mold option, and then we look after that maintenance, and there's no additional charge.
Yeah, so coincidentally, Luke asked pretty much, I think, the question that you answered. I'm not sure, Luke, if Richard fully answered your questions. Are you there, Luke? His message back to say you answered it. Yeah. Okay, great. Anybody else have any questions? I was going to ask you on Richard, how you got into how did you get to where you are now, from leaving school and getting into this particular role and position?
So I studied furniture design at university initially, so more of a creative thing rather than an engineering thing. But as part of that, I did a dissertation on rapid prototyping, so kind of looking at what the technologies were as they were back then. And then after that, I did a master's. I did a research MSc on rapid prototyping, so additive manufacturing. It was more kind of focused on how it can be used within creative industries, sort of taking it from that angle. And then from there, I got a job at Protolabs, and at that stage, all they did was injection molding and CNC machining. So I was almost going to the kind of polar opposite of what I was doing at my studies. They didn't do 3D printing. They did like the opposite. They were doing traditional injection molding but fast. But then over the years, they then entered the additive manufacturing market. And I've I started off at Protolabs analyzing the CAD files for their suitability for injection molding, and then designing the mold tools. And then from there, I've moved to a more customer-facing role, kind of using that experience to help customers kind of interpret the sort of information we provide. So for injection molding, we provide a lot of information in our quotes. And if you're not used to that, that can be quite overwhelming to understand what are the important bits and what are the bits that probably could be okay. So part of my role is helping customers to understand what that all means, and then to sort of interpret which bits are going to be a problem and which bits are probably not going to be a problem, and sort of helping them to sort of weigh up whether they should adjust their design based on some information we've put in our analysis feedback, or whether it's probably going to be okay.
Yeah, interesting. I think I'll stop the recording now. That might encourage people or not.